Gaussian elimination. Now, this comes from, the name comes from the famous mathematician Carl Friedrich Gauss. Have you heard of him before? Yeah. He was like sometimes if they would go greatest mathematicians of all time, he's almost always listed as one of them. Gaussian elimination. Now, if you had this system of equations, it would be really easy to solve, especially for y. Agreed? Because in that system of equations, the second equation tells us y is equal to 2. Pretty hard to solve for. But then you could plug that 2 back in, and you would figure out that x is equal to -1. Now, what we're going to do with a system of equations like this is we're going to write something called an augmented matrix. So this matrix has the square matrix of the coefficients and the column matrix of the answers put together. And we usually draw a line here to separate where the equal signs were. So this tells us that y is equal to 2 and 1x plus 2y is equal to 3. And any equation where this bottom number is a 0 is really, and this number is a 1, is really easy to solve for y. So what we're going to do is we're going to learn how we can change any matrix, any augmented matrix, so that that bottom left corner is a 0, which is called row echelon form. Whenever you get the bottom numbers to be zeros, that's row echelon form. And once you have it in row echelon form, you can right away figure out what y is, because it'll just be y equals something. And then plug it back in to find the rest of the values. And this idea is called Gaussian elimination. So what we're going to do is we're going to create our augmented matrix and then use something called elementary row reducing operations. This is basically the same idea as elimination, but it allows you to work with it within your matrices. What are the elementary row operations? You can switch any 2 rows around. In other words, in my equations before, would it still be the same answers if I had written y equals 2 first and x plus 2y equals 3 second? Yes. Switching the rows around won't change your answers. You can multiply a row by any non-zero number. Is that true of an equation? If you multiply both sides by 2, is the equation still equal to each other? Yes. And you can add a multiple of 1 to a multiple of the other. Whoops. Okay. So here is our first matrix. If we wrote this out as an augmented matrix, 1, -2, 10, 1, 4, 16. Our goal is to make the bottom left-hand corner a 0. And what we do to show our work is we come up with a way that I could make that a 0 by either I can interchange rows, I can add and subtract rows, I can multiply rows by things. Can you see if I changed row 2 to equal row 2 minus row 1? That's following, as far as my elementary row operations go, I can add a multiple of one row to another. So I'm going to rename row 2 as row 2 minus row 1. So because my instructions that I've written down says I'm renaming row 2, Row 1 stays the same, 1, negative 2, and 10. But if I do row 2 minus row 1, can you see that this would become a 0? 1 minus 1. And 4 minus a negative 2, this will become a 6. And 16 minus 10, this will become a 6. And what we just did now in this second equation is we just said 6y is equal to 6. What's y?
1.
Y is 1. And if y is equal to 1, you could plug it back into equation 1, and now you'd have x minus 2 is equal to 10, and x is equal to 12. So Gaussian elimination is interested in getting that bottom corner to be a 0. And if you get it to be a 0, then you can quickly solve that second equation for y, plug things back in to solve our first equation as well. So I know that on these ones I start to give you not very much space in your notes. So you may want to have, because some of these can take a lot of space later on, so much that I'd have to give you pages and pages of openings. So you might want to have some, I have some extra loose leaf if you like to work on there. If you think you could write small and it would fit in there, perfectly fine. But we will have some later ones that like take a whole page of paper just to figure them out. Let's do another one together. Write our augmented matrix. 2, negative 3, negative 2, 4, 1, 24. How could I make this one a 0? Well, I want to change row 2, and I want row 2 to equal row 2 minus row 1 would just get me 2, but if I subtracted 2 row 1s, would that give me a 0 in that bottom corner? Okay, row 1's not changing, because my instructions say I'm only changing row 2. 4 minus 2 times 2 would be 0. 1 plus 6 would be 7. And 24 minus 2 times negative 2 would be plus 4, would be 28. This tells me that 7y is equal to 28. So y is equal to 4. If y is equal to 4, I can go back to my first equation. 2x minus 3 times 4 equals negative 2. 2x equals 10. X is equal to 5. Again, we often write our solutions as coordinates, so our solution would be 5, 4. The idea that we're doing here is really elimination, right? We're really multiplying row 1 by negative 2 and then adding the 2 rows and seeing what you get and going from there. But the nice thing is it keeps things contained in a matrix, so it's a little bit cleaner than just working with the equations. Also, Because you're working with a matrix, you don't have to rewrite the x's and the y's every time, which also makes it easier to do. What would we have to do with this one first? Rearrange it so that you can write your augmented matrix. All right, I'll get you to try this one. I'm going to show you guys something that you can do. So when I set up my augmented matrix, sometimes doing too much mental math at once, this will be -3, 1, 1, 1, -2, -6. Sometimes doing too much mental math at once can cause you problems. So you might want to take an extra step and say, I'm going to make row 2 equal to 3 times row 2, because I'm allowed to multiply a row by a number. If I do that, row 1 stays the same. And now row 2, which has been multiplied by 3, is now 3, 3, -18. If I do that, it's really obvious that now if I add the 2 rows together, that I'm going to get a 0 where I want it to. So I can do a second. Now I just want to change row 2 to equal row 1 plus row 2. Again, row 1 doesn't change. But now when I add the rows, this will be 0. 1 plus 3 is 4. -2 plus -18, -20. And so I know that 4y's equal -20, y is equal to -5. So we have to do quite a bit of mental math here. You could have put this together by saying I want row 2 to equal row 1 plus 3 row 2's and done it in one step. But sometimes doing it in one step will cause you to make a mental math error. So you might want to take an extra step. Just multiply a row by something. And then once you get y is equal to -5, plugging that back in, I think you get x is equal to -1. So once you've figured out the next one, now we go to a 3 by 3. And your job is to get all 3 of these to be zeros. You will need some loose leaf for this. Again, the rules are the same. You can add any two numbers. Any 2 rows together. You can add a multiple of a row to another row. Just need to describe what you're doing to get those zeros.